Now the question here is, what is volt? Well, on your book, or in your book, somewhere, it says what an electron volt is. Where is this? Where is this? Yeah, there it is. An electron volt is 1.6 times 10 to the minus 19 joules. So an electron volt is 1.6 times 10 to the minus 19 joules. Pretty familiar, actually. 1.6 times 10 to the minus 19. That should look very familiar. It is the charge of one electron. Yeah, from chemistry. Well, from physics too, right? So that is a charge of one electron. So yeah, we can use that by saying kinetic energy is 13.6 times that. You get it?
Yeah.
So 13.6 times 1.6 times 10 to the minus 19 gives you what? It's going to be like 19 or 18 or something?
2.17 times 10 to the negative 18.
Oh, wow. Okay, so 2.2 times 10 to the minus 18. So minus 18 joules. See, so now we have the number of joules. And that's what it's going to go under here in kinetic energy. So then, the number of passes per second is going to equal the current. Because it'll be the number, like each time the pass goes by, that'll be a charge. Wow, this could be.
What does Q represent?
Sorry, Q is charge.
Charge.
Okay.
In this case, number of passes equal to charge.
Well, every time a pass goes by, you get one of these electron. Jeez. Each time the charge goes by, each time the pass happens, you get one electron passing. And then what you have to do is when you get the number of passes per second, then you have to turn the number of passes into coulombs. So once you have the number of passes per second, then you multiply this by 1.6 times 10 to the minus 19 coulombs per pass. Yeah. And unfortunately, I can't see any simple way to get out of, like, well, maybe there is. Nah, there's no simple way, because you've got to have the velocity in meters per second in order to do this with the circumference. Yeah.
Didn't we then just, they give you R, so couldn't you just, when you find the velocity?
So we got 2.2 times 10 to the 6 meters per second by using this mass and this kinetic energy. Then we get, in order to find the passes per second, I take the circumference using this radius and divide by the velocity. That gives me 1.5 times 10 to the minus 16. So I get a ridiculously tiny current. I mean, an electron moving around an atom, how much current would you expect? Correct this now. Okay, so what we did, we did the velocity perfectly well, and what we did here, the number of passes per second should have been over circumference, because velocity is meters per second. When you divide meters per second by meters, you just get something per second. So that was my mistake there. So if you do this, then you get that, 6.7 times 10 to the 15. And when you multiply that by the charge of 1, then you're good. So to kind of walk, what you're going to first you find, and from the KE you find the velocity. Then you take the velocity divided by the circumference, which gives you the number of passes per second. Then you take the number of passes per second, you multiply it by the charge per pass, and that gives you coulombs per second. Right? And to get kinetic energy, we had to take electron volts and convert it to joules. So we did electron volts to joules. We took the kinetic energy, got a velocity, took the velocity divided by the circumference, then we took the number of passes per second, multiplied it by the charge per pass, and got this. And of course, this charge per pass was 1.6 times 10 to the minus 19 coulombs per pass, because one electron goes by every pass. And then the electron volts to joules is 1.6 times 10 to the minus 19 joules per electron volt. So we use that as a conversion, and this is the logic of the problem.